Good morning. Welcome to MCS TV. I hope this recording finds you and your family doing well. My name is Miss Townsend. I teach 5th grade Science and Social Studies at Cypress Point Elementary. Today we're going to talk about matter. Matter is all around you, from the teeniest, tiniest atom of air to the biggest structure that you can imagine. The Golden Gate Bridge, the Eiffel Tower, or the Statue of Liberty. Matter can change, and today we're going to talk about the physical and chemical changes that matter can undergo. So our objectives for today's lesson is I'm going to start out by giving you definitions and examples of some physical changes and some chemical changes so that you can distinguish between these changes. And then I'm going to demonstrate some chemical reactions taking place so that you can actually see the evidence of those changes as they happen. So let's talk about physical changes first. Physical changes can alter the form of material, but it doesn't change what the material is actually made of chemically. Physical changes can sometimes be undone or reversed, such as changing the states of matter. For example, to turn a liquid such as water into a solid, such as ice, you would need to take away heat. For example, you could put it into your freezer overnight and you would have ice the next morning. To turn that solid back into liquid water, you would need to add heat. So you could put it in a pan on a stove and that ice would melt back into liquid. And if you continue to add heat to this liquid, it would then become a gas and evaporate out of the pan, which is evidenced by the steam you would see rising out of the pan. When you cut, slice, tear, shred, chop, or smash something, those are all physical changes. The objects can change in size, shape, and sometimes even its texture can change. But you still have what you started with. So take this tree here. This tree is made of wood. Wood can be cut, it can be chopped into smaller pieces, sliced into slices, shredded into wood chips, or even ground into sawdust. So after you do any of that, you still have what you started with, and that is wood. Other examples of physical changes include painting a wall, because you're only changing the color of the wall. Cutting a paper, you're changing the size and the shape of the paper. And even breaking glass, you're changing the size and shape of glass. But after you finish, you still have what you started with. So chemical changes are a little bit different. They are caused by a chemical reaction, which is when something new is created when you mix things together. Unlike a physical change, chemical change usually cannot be reversed or undone. So some evidence of a chemical reaction is an unexpected change in color or odor. So if you just color on a sheet of paper, that's not an unexpected change, because you know if you color with a green crayon, you're going to have green paper. But I'm going to show you in just a minute what an unexpected change in color looks like. Sometimes an odor is formed when there is a chemical reaction. You see a formation of a gas, maybe. You might see bubbles and know that a gas is forming. And then sometimes you might see a formation of a precipitate, which is when a solid forms by mixing two liquids. And then, of course, anytime energy is given off in the form of heat or light, that's also a sign of a chemical change. So I'm going to do a few demonstrations for you to show you some of these signs of a chemical reaction. So if you'll follow me over to my table. The first demonstration I'm going to do is I'm going to take a half a cup of water, and if you notice the water is clear, it's a liquid, and then I'm going to take a few drops of iodine, and it may be hard to see, but iodine has a yellowish orange color, maybe almost a brown tint to it, but it is also a liquid. So when I take my cornstarch, which is a starch, it's a white powder. I'm going to take a tablespoon of cornstarch and I'm going to mix it into my water. The cornstarch is white, and when you mix it with water, it becomes a white liquid. We're going to mix it up real good here. All right, kind of looks like milk, doesn't it? I'm going to take some of this iodine up into my syringe, and you can see a little bit better the color of the iodine. Now, when you mix orange with white, you would expect to get an orangish yellowish tint. But watch what happens when I mix the iodine into the cornstarch liquid, and I give it a good mix here. You'll see that the color actually changed to a purple, and it's really pretty when you put it under a bright light, but it's kind of a light purple color under a light. So that is an unexpected color change. The next demonstration is going to demonstrate a gas being produced. So I have 100 milliliters of vinegar here, just white vinegar, and I'm going to put about 3 tablespoons of baking soda into my balloon here. And if you wonder why are you using a balloon, I will show you that, you'll see. So I made a little homemade funnel with some paper, and I'm gonna drop the baking soda into this balloon. The reason is I don't want it to mix just yet with my baking soda. So, 3. Make sure it gets all in there, into the balloon. Shake it a little bit, get it down in there. Okay. All right, there it goes. Now, I'm going to try to be careful not to spill the baking soda into the vinegar yet. I want to stretch this balloon over the top of my flask so that none of the gas escapes. I want you to look closely as I mix the baking soda with the vinegar and see what happens. Here we go. Automatically, you see some bubbles being formed, and look what happened to the balloon. The balloon expanded, which proves that a gas was created. So as you can see, the bubbles being formed in there, mixing vinegar and baking soda creates a chemical reaction. All right, moving down to the next experiment. I'm gonna wash out my dropper here so we can reuse it. My next experiment here, I have half a cup of water. Oh, I forgot to turn my heat on. I'm gonna turn my heat on my water here. I have half a cup of water, and I'm going to go ahead and mix a tablespoon of sodium carbonate, which in the store is the same as laundry detergent such as borax. I'm going to mix a teaspoon of that into this water. Stir it up really good until it dissolves. And here I am creating a solution because once I mix these together, it cannot be unmixed. So that is a solution. And then I'm going to take some Epsom salt and add it to some warm water. I'm going to go ahead, I'm warming my water up now. I'm going to put a tablespoon of Epsom salt in it. Okay. And the reason I'm warming up the water is whenever you heat water, it helps things to dissolve a little bit faster to get that total dissolve. So I'm going to go ahead and put my pot holder on because anytime you mess with heat, you don't want to burn yourself. It should be warm. We'll pour just a little bit of water in here, not a whole lot. And I'm going to put my Epsom salt in, and I'm going to try to dissolve it as much as possible. So I'm going to give it a good stir here. And you want to stir it until you can't see big pieces floating around anymore. So here we have 2 liquids. We have a sodium carbonate solution and an Epsom salt solution. So you would think if you mix these 2 liquids together, you're going to get a liquid, right? Well, to make it easier to see, I'm going to drop a couple of drops of food color into my Epsom salt solution. And all that's going to do is make it easier for you to see when we drop it into our sodium carbonate solution. So give that a stir. You still have a liquid. I'm going to pull some up into my dropper, and I want you to look very closely as I drop it into the sodium carbonate solution. You can already see the color going into the solution. And what's being formed in there is a soft solid. In just a minute, you'll see the pieces floating around. So you can actually see that that is a solid inside that cup. You see the pieces floating around in the liquid. So mixing these two liquids together formed a solid. That solid is called a precipitate, and that is a sign of a chemical reaction. Pretty cool, huh? All right, the next evidence of a chemical reaction is giving off heat and light energy. So I'm gonna simply strike a match, and as you see, it gives off light, it gives off heat, and I don't know if you can see it, but it's also smoking. Watch when I blow this match out. Now you can definitely see the gas that's being given off of the match. So that's a simple chemical reaction. And if you look in my bowl, I burned a piece of paper before this recording began. You can still see I still have paper here, but this material right here is very soft and it's very powdery. We call this ash. So when you burn paper, something new is created, and that is a sign of a chemical reaction. If you put this material under a microscope, it would have a different chemical makeup than this paper would. So just remember that when you have a chemical reaction, something completely new with new chemical properties is created. So we're going to go back over to the board. I hope you enjoyed those demonstrations. And just some other examples of chemical reactions include baking a cake. Anytime you bake materials and add heat to it, it causes a chemical reaction. The leaves turning colors in fall, that's an unexpected color change. Fireworks exploding in the sky gives off heat, because if they ever went off in your hand, it would burn your hand. They give off heat and light when they mix. Burning toast, if you'll notice, it turns black. If you've ever felt toast, it's very crisp and brittle. It has an odor to it, so that's an odor, a color change, and the texture has changed. And then also, anytime you've ever seen fruit rot, like a banana turning black, if you've ever seen a banana turn black and felt it, it's very mushy. The color has changed and it smells really bad. Same thing with an apple. You'll see the color change and it'll get soft and mushy on the inside as well. So those are other examples of chemical reactions. Remember, they cannot be undone once they have reacted. Now, it's your turn. I want you to tell me whether the following examples are physical changes or chemical changes. So you may have to pause your video after I say each one to see if you can guess the correct answer. The first one is breaking a crayon. Would that be physical or chemical? It would be physical because you're only changing the shape and the size of the crayon. It is not changing to a new material. The next one is lighting a campfire. Would that be physical or chemical? That would be chemical, that's right, because just like our match, you are giving off light and heat. And then the wood that you're burning would become ash, just like our paper did. The next one is chopping a banana. Would that be physical or chemical? Very good. That would be physical because all you're doing is changing the size and the shape. You still have a banana. And then last is frying an egg. Would that be physical or chemical? Very good. That would be chemical because just like our cake, we are cooking it, we're adding heat, and it changes to something completely different. So, how did you do? Do you now understand the difference between physical and chemical changes? I hope you've enjoyed this segment. Stay tuned for more episodes of Science from MCS TV. Have a great day.